So in this question, we're told that there is a sandwich menu, a soup, and a salad menu. And then they give you a relationship between the numbers. The number of salads listed is twice the number of sandwiches. So I'm just going to call these X, Y, and Z. So the translation is number of salads. And it can be tricky as you're reading this to get wrapped up in these different relationships. It's twice the number of sandwiches, so 2X. And one more than the number of soups listed, so Y plus 1. That's the translation. Question is how many soups? So Y is the variable of interest. So I'll start with statement 1 says total number of choices a customer has when choosing one item from each of two of the menus. So if we start with just these two, I have X choices for the sandwich and Y for soup, so the number would be X times Y because you're choosing one from each of the two menus. Then you find the next pair, meaning a sandwich and a salad menu. That would give you X times Z. That's the basic counting principle. If you have X choices for sandwiches, Z for salad, that would be the total. And then finally, we have soup and salad combination. That would be YZ. So it's in this sum that's given to us as 63. Since I'm interested in Y, I'm going to replace everything else in terms of Y. So X is Y plus 1 over 2, Z is Y plus 1, and then I'm going to replace that here. Maybe some other way of defining the variable would be better, but sometimes when you're doing this in the exam, you just set it up as it comes to you. You don't really have the luxury of changing the strategy. And then Z is Y plus 1. So here you'll note I can factor out the Y plus 1. So I'll get Y over 2, Y plus 1 over 2, and then Y. So we'll do 2Y over 2. So sometimes you have to do this algebra. So that would be 4Y plus 1 over 2. So we get this quadratic, 4Y plus 1. Y plus 1 equal to 126. If you do the expansion here, you will get 5y plus 1 minus 126. And the question is, do we need to solve this? Well, we know that the product of the two roots, so we'll have two roots, is negative, because if these are the two product roots, it's c over a, which is minus 125 over 4. And that means one is positive, the other is negative. And that's important for uniqueness because the key is, do we have a unique value? And since there's only one positive value, yes, we do have a unique value. So 1 is sufficient. You don't have to solve for it. I mean, you can guess the number here. If y was, I think I tried it earlier. I think y is 5, so that would be 21, and then 6. Yeah, that would work. So you have to see whether that's worth it doing in the exam or not. Statement 2 says when you're choosing one item from each of the three menus, the total number of choices is 90. So that would be X choices for the sandwiches, Y for the soup, salad, Z. So that's the condition. And if I replace X in terms of Y, that's the condition I get. And this would mean Y times Y plus 1 square equal to 180. And then I guess the hard part with this question is, do we have a unique value? And clearly sometimes you can use the answer you get for statement 1, even though you're supposed to keep them separate. But we have 5 here. I can try that here. 5 times 5 plus 1, 6 square, which is 36 times 5, does work. So we know y equal to 5 is a solution. The only tricky part here is, how do we know that that is the only solution? And I think I honestly don't know if there is a clean way of doing that. So I'm just going to write this because it's a cubic equation. Y cubed plus 2y squared plus y minus 180 equal to 0. So we know y equal to 5 is a solution, which means y minus 5 is a factor. So I don't know. This seems overkill for the GMAT. So there's maybe an easier way to argue, and I just don't know right now. I don't know. I don't think I'll be doing this in the exam. I would probably just say, okay, there's one value that works. Then there's no other value. Maybe one way of arguing that is if I look at this, we know that's going to be always positive, so that tells me y is positive. But the question is, in a cubic, you can have 3 roots. So how do we argue that the other 2 roots don't give me another value? So this is not really, I don't think I've ever seen this in the GMAT, where you're dividing this to find what's factor is left. So I'll just do that for completeness here. But I should tell you that I'm not sure this is where anyone wants to go, needs to go. So 7y squared plus y plus 7y squared minus 35y. This will become 36y minus 180. And then I put a 36 here, which will give me a remainder of 0. So we do expect that to be a factor. But the key thing is this factors out to y minus 5 times y squared plus 7y plus 36 equal to 0. That just gives me 5. Does this give me any other solution? You'll notice that the discriminant, which would be 7 squared minus 4 times 1 times 36, is negative. That means there are no real roots. This will not give us any solution. So therefore, there has to be one unique value, and therefore 2 alone is also sufficient. Answer is D. So honestly, I don't know how I could go from this step to argue that there's only one solution. I mean, I showed you how it makes sense to me, but honestly, I don't think this is how the GMAT writers want you to think. So maybe there's something I'm missing right now. If I figure it out, I'll definitely update that here. But for now, this is how I've been thinking about this question.